The question is saying that figure 8.5 shows a capacitor made of two circular plates, each of radius 12 cm and separated by 5 cm distance. The capacitor is being charged by an external source not shown in the figure. The charging current is constant and is equal to 0.15 ampere. Now we have to calculate the capacitance and the rate of change of potential difference between the plates, and we also need to obtain the displacement current across the plates, and in third we have to tell whether Kirchhoff's first rule or the junction rule is valid at each plate of the capacitor. Now we know that capacitance is defined as C equals to epsilon naught A by D, which depends upon the geometry of the plate. Here we have been given that the radius of each plate is 12 cm and they are separated by 5 cm distance. That is, the radius of this plate is 12 cm and they are separated by 5 cm. We also know that rate of change of potential difference is dV by dt. Now V in terms of the capacitance is defined as Q by C, where Q is the quantity of charge. Now if we differentiate V with respect to T, then we will come to the expression of 1 by C dQ by dt, and we can write dQ by dt as I, that is current. So rate of change of potential difference would be equal to I by C. Now let's find out the expression for displacement current. Now we know that displacement current is defined as epsilon naught d phi E by dt, or the rate of change of flux, and flux is defined as E dot A, the dot product of electric field and the area vector. Now E is defined as sigma by epsilon naught, where sigma is the charge density of the plate, so we can write it as Q by A. Now if we find out flux, then A will get cancelled out. Now flux would be Q by epsilon naught. Now displacement current is defined by epsilon naught d phi by dt. After substituting this flux in this expression, we will get epsilon naught multiplied by dq by epsilon naught. So it would be cancelling the epsilon naught and we will get the value of displacement current equals to I. So the displacement current would be equal to conduction current. Now let's compute capacitance. Capacitance was epsilon naught A by D. After substituting the area and the displacement and the distance between them, we will come to the conclusion that the capacitance is equals to 8 picofarad. Now computing the rate of change of potential difference dV by dt, we already know from here we have calculated that dV by dt would be equal to current by capacitance. Now substituting that in this expression, we will get a value of 1.87 into 10 to the power 10 volt per second. Now computing displacement current, we already saw from this derivation over here that displacement current would be equal to conduction current. So displacement current would be equal to 0.15 ampere. Now it follows the Kirchhoff's junction rule, as at each plate the conduction current flows into the one side while the displacement current flows out of the other side. The question says that a parallel plate capacitor in figure 8.6 made of circular plates, each of radius 6 cm, has a capacitance C is equals to 100 picofarad. The capacitor is connected to a 230 volt AC supply with an angular frequency of 300 radians per second. Now we have to calculate what is the RMS value of the conduction current, and is the conduction current equal to the displacement current. And in third question, we have to determine the amplitude of B at the point 3 cm from the axis between the plates. Now we know that capacitance is a relationship between the charge and the potential difference across the capacitor, and it is given by C equals to Q by V, where Q is the charge and V is the potential difference. And the conduction current for AC voltages, the RMS conduction current is equal to IC equals to omega C by omega C V RMS. Here it comes from V RMS divided by the impedance XC, and we know that XC is for the capacitor is 1 by omega C. So we will get the conduction current as omega C V RMS, and the peak current is related to the RMS current as I peak equals to √2 I RMS, and magnetic field at a distance r from the axis between the plate is mu naught I peak r by 2 pi r square, where r is the distance of the point from the axis of the plate, and this capital R is the radius of each circular plate. Let's calculate the conduction current. We have been given the capacitance, that is 100 picofarad, and Vrms is 230 volt, and omega, the angular frequency is 300 radians per second. So RMS current would be equal to IC omega C Vrms. Now substituting in this formula, we will get a value of 6.9 microampere. So the conduction current is going to be equal to 6.9 microampere. Now let's calculate the displacement current. So displacement current arises due to the changing electric field in the capacitor, and Maxwell's equation predict conduction current equals to displacement current. Now since the capacitor is connected to an AC source, the time varying electric field ensures IC equals to ID. So yes, IC is equal to ID here. The conduction current equals the displacement current. Now calculation for the peak magnetic field. Now for calculating the magnetic field amplitude, we will use the peak current. So we will use this formula, mu naught I peak r by 2 pi r square. So substituting the values in this formula, we will get a value of 1.63 into 10 to the power minus 11 Tesla. Thank you. The question is saying that what physical quantity is same for X-rays of wavelength 10 to the power minus 10 meter, red light of wavelength 6800 angstrom, and radio waves of wavelength 500 meter. So basically it is saying that what quantity is same for all these electromagnetic radiations, or what quantity is same for electromagnetic radiations. So electromagnetic radiations has same speed, because they all travel with the same speed of approximately 3 into 10 to the power 8 meter per second. Now this constancy arises from the Maxwell equation, which predicts the electromagnetic waves are self-sustaining oscillations of electric and magnetic fields. We also know that C, or the speed of electromagnetic wave, is equals to frequency times lambda. So this speed is going to be same. What changes is wavelength or the frequency. Thank you. The question says that a plane electromagnetic wave travels in vacuum along z direction. What can you say about the direction of electric fields and magnetic field vectors? Is the frequency of wave, if the frequency of wave is 30 megahertz, what is its wavelength? Now we know that electromagnetic waves consist of oscillating electric and magnetic fields that are perpendicular to each other and from the direction of the wave propagation. These fields are described by Maxwell's equation, which predict that E and B are perpendicular to each other. Both E and B are perpendicular to the propagation vector k, that is the direction in which wave is propagating, that is in the z direction. So both E and B vector is going to be perpendicular to the z axis or the k cap direction. Now for a wave propagating in z direction, E would be perpendicular to the z, and B is also going to be perpendicular to z, and E and B are mutually going to be perpendicular. So you can assume that E is along the x-axis and B is along the y-axis. Now we have to find out the wavelength of the wave whose frequency is going to be 30 megahertz. So the frequency of the wave is given as 30 megahertz, or 30 into 10 to the power 6 hertz. The formula for calculating wavelength is the speed divided by frequency. So speed is going to be 3 into 10 to the power 8 meter per second, which is going to be constant, and frequency is 30 megahertz. So after dividing it, we will get a value of 10 meter, that is wavelength is 10 meter. Thank you. The question is saying that a radio can tune into any station in 7.5 megahertz to 12 megahertz band. What is the corresponding wavelength band? So we know that the wavelength can be defined by the speed divided by frequency, and we have to find out here that given the range of frequency, what is the range of wavelength? Wavelength band means the range of wavelength. So here lambda can be calculated by dividing the speed with frequency. So let's calculate. The highest frequency is 12 megahertz and the lowest frequency is 7.5 megahertz. So corresponding with the lowest frequency there will be the higher wavelength, that is for frequency maximum 12 megahertz the wavelength is going to be 25 meter, and for the lower frequency lambda is going to be maximum, that is 40 meter, because lambda equals to c by nu and nu equals to c by lambda. So they both are inversely proportional. So if frequency is maximum, lambda is going to be minimum, and if frequency is minimum, then lambda is going to be maximum. So we come to the conclusion that the wavelength band is going to be 25 meter to 40 meter. Thank you. The question says that a charged particle oscillates about its mean equilibrium position with a frequency of 10 to the power 9 Hz. What is the frequency of electromagnetic waves produced by the oscillator? So we know that accelerated charges radiate electromagnetic waves, and the frequency of the electromagnetic waves equals the frequency of the oscillation of the charge. So we can say that the frequency of the wave produced is identical to the frequency of the oscillating charge, and it is going to be same, that is 10 to the power 9 Hz. So the frequency produced, the frequency of the electromagnetic wave produced is going to be of the magnitude 10 to the power 9 Hz. Thank you. The question says that amplitude of magnetic field part of the harmonic electromagnetic wave in vacuum is B naught equals to 510 nanotesla. What is the amplitude of electric field part of the wave? So we know that electric field and magnetic field are related, as electromagnetic wave consists of oscillating electric and magnetic fields. These fields are perpendicular to each other, and the direction, and they are also perpendicular to the direction of the wave propagation. And the amplitude of the field is given by, they are related by E naught equals to CB naught, that is electric field magnitude is equals to the speed of electromagnetic wave times the magnitude of magnetic field. Now here speed of the electromagnetic wave is 3 into 10 to the power 8 meter per second. Now we have been given the value of B naught, that is the magnitude of magnetic field. We have to find out the value of E naught. So in this formula only E naught is the unknown. We know the value of C and we know the value of B naught as it is given in the question. So substituting in this formula we will get a value of E naught, that is the magnitude of electric field, as 153 Newton per Coulomb. Thank you. The question says that suppose that the electric field amplitude of an electromagnetic wave is E naught equals to 120 Newton per Coulomb and its frequency is 50 megahertz. We have to determine the magnitude of magnetic field, omega, angular frequency, k wave number, and the lambda, that is the wavelength. So we know that B naught equals to E naught by C, or the magnetic field magnitude is equals to the electric field magnitude divided by the speed of electromagnetic wave. So upon using this formula we will get the value of B naught, that is 4 into 10 to the power minus 7 Tesla. For angular frequency we know that angular frequency is 2 pi by T, or 2 pi nu, or 2 pi into frequency. We haven't given the value of nu, so we can easily calculate angular frequency omega over here, that is 3.14 into 10 to the power 8 radians per second. For wavelength, we know that the formula is the speed of electromagnetic wave divided by the frequency. After substituting the values, we will get the value of 6 meters. So this is the wavelength. For wave number, we know that it is 2 pi by lambda, or the wavelength. So after substituting the values, we will get a value of 1.05 radians per meter. So this is the wave number. Having calculated all these values, we have to now find out the expression for E and B, that is electric field and magnetic field. So we assume that electromagnetic wave is moving in the x direction. So electric field will be along y direction and the magnetic field will be along z direction. So this is the general expression for the electric field and the magnetic field. Now substituting the values of E naught, that is the peak magnitude of electric field, and k, that is the wave number, and omega, that is the angular frequency, we will get the expression for electric field of this electromagnetic wave. Similarly, substituting the values of corresponding values of the magnetic field, that is the magnetic field magnitude, wave number and all, we will get the value of the expression for magnetic field in this electromagnetic wave. Thank you. The question says that the terminology of different part of electromagnetic spectrum is given in the text. Use the formula E equals to h nu for energy of quantum radiations, photons, and obtain the photon energy in units of electron volt for different part of electromagnetic spectrum. In what way are the different scales of photon energies that you obtain related to the source of electromagnetic radiations? We have to find out photon energy, or the energy of these electromagnetic radiations, and the band is this. For radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays, we have to find out their energy in electron volts, and also we have to find that we have to give a way, we have to tell in what way are the different scale of photon energies that you obtain related to the sources of electromagnetic radiations. So let's start. We know that energy of a photon is given by E equals to h nu, where h is the Planck's constant with the value of 6.63 into 10 to the power minus 34 joules second, and nu is the frequency of the radiation. Now if we relate joule with electron volt, then 1 joule would be equal to 6.242 into 10 to the power 18 electron volt. Now frequency and wavelength are related using this formula, that is C equals to nu times lambda, or we can say that frequency is equals to C by lambda, where C is the speed of the electromagnetic wave and lambda is the wavelength. Now this is the table which represents the electromagnetic spectrum with their wavelength and the energy level. So we can see that as the wavelength is reducing, frequency is increasing and energy is also increasing. We can see that the least energy is of that of the radio waves, which is having a much higher wavelength, much higher than 0.1 meter, and they have frequency of less than 3 into 10 to the power 9 hertz, and they have energy less than 10 to the power minus 5 electron volt. And the gamma rays is having the least wavelength, that is of order of less than 10 to the power minus 11 meter. They are having higher frequencies, 3 into 10 to the power 19, and the energy, they are having the highest energies of 1.24 into 10 to the power 3 electron volt. Now we in this pattern we see that the photon energy increases with frequency and decreases with wavelength, and also we see that higher frequency electromagnetic waves are more penetrative and interact strongly with the matter. Now these kind of these diversity in photon energies allows electromagnetic waves to be utilized in various applications. Thank you. The question says that in a plane electromagnetic wave, electric field oscillates sinusoidally at a frequency of 2 into 10 to the power 10 hertz and the amplitude of 48 volt per meter. Now what is the wavelength of the wave? What is the wavelength of the wave and what is the amplitude of oscillating magnetic field? Show that the average energy density of E, that is electric field, equals the average energy density of magnetic field. We have been given the speed of electromagnetic wave as 3 into 10 to the power 8 meter per second. Now we know that electromagnetic waves consist of oscillating electric and magnetic fields which are perpendicular to each other, and they are also perpendicular to the direction of the wave propagation. Here we have to find out the wavelength of the wave and the amplitude of the oscillating magnetic field, and that is B naught. We have to find here B naught, and we have to find out lambda over here, and we also need to show that the average energy density of E electric field equals the average energy density of magnetic field. So the formula for calculating wavelength is speed of the wave divided by frequency. But before that, we should clear some of the facts. The speed of electromagnetic wave in vacuum is 3 × 10⁻⁸ meter per second, and the relationship between electric field and magnetic field is given by B naught, that is the magnetic field is equals to electric field divided by the speed of this electromagnetic wave. Now energy density of electric field and magnetic field is given by the electric field energy density is epsilon naught, the magnitude of electric field square divided by 2. Similarly, for magnetic field, the energy density is given by the magnitude of magnetic field square divided by 2 mu naught, where mu naught multiplied with epsilon naught is equals to 1 by c square. So let's calculate the wavelength. The frequency of the wave was 2 × 10⁻⁻10 hertz, and the speed of the light was c equals to 3 × 10⁸ meter per second. So for formula for calculating wavelength is c by frequency, that is the speed of the wave by frequency. Now lambda, upon substituting the values over here, we will get a value of 1.5 × 10⁻⁻2 meter. So the wavelength is going to be equal to 1.5 centimeter. Now let's find the magnitude of magnetic field. So we will use the formula, this formula over here, B naught equals to E naught by C. Electric field amplitude is given as 48 volt per meter, and the speed of light is given as 3 × 10⁸ meter per second. So upon substituting the values over here of E naught and C, we will get a value of B naught, that is the magnitude of magnetic field, as 1.6 × 10⁻⁻7 Tesla. Now we have to show that the energy density of electric field and magnetic field are same. So we will see the expression for electric field density, that is epsilon naught E square by 2. Similarly, for magnetic field it is this. Now using epsilon naught into mu naught equals to 1 by c square, and this the relationship between electric field and magnetic field magnitude, we will come to a conclusion that EB is equals to UE, or the energy density of electric field is equals to energy density of magnetic field. Thank you.